Hi, myself and Krishna Rao, working as Assistant Professor, Department of Civil Engineering, Mlritm, Hyderabad. So now the subject name Advanced Prestressed Concrete Structures, and the topic name is Introduction and Losses of Prestress. So now go through the course objective. So to critically review the techniques of prestressing, both pre-tensioning and post-tensioning, to design the prestressed concrete members for ultimate and limit state of serviceability, to realize the importance of statically independent structures and load balancing. Fourth one, to analyze the design and continuous prestressed concrete beam with bent cables having straight and parabolic profiles. Now go through the after the completion of the course, the student able to learn the course outcomes. First one is realize the importance of prestressing long span structures and heavily loaded members. Second one, acquire the knowledge of the various pre-tensioning techniques, their merits and demerits. Develop skills in planning, analysis and design of prestressed concrete beams and slabs. So now go through the fourth one, develop skills that satisfy the serviceability and strength provisions of made of IS standards 1343 2012. Now go through the syllabus. The first unit, introduction, prestressing systems, pre-tensioning systems, post-tensioning systems, high strength steel and concrete, analysis of prestress, resultant stress at the section, pressure line, thrust line, concept of load balancing. Losses of prestress. Due to the losses of prestress, the elastic deformation of concrete and shrinkage of concrete, creep, relaxation of stress in steel, friction, anchorage, slip. Go through the second unit, deflections of prestressed concrete members, importance of control of deflections, factors influencing of deflection, short-term deflection, uncracked members, prediction of long-term deflections, deflections of cracked members, requirements of 1343-2012. Ultimate flexural strength of beams. Introduction, flexural strength and first principles, simplified methods, ultimate moment of resistance of untensed steel. Go through the third unit, composite construction, introduction, advantages, types of composite constructions, analysis of composite beams, differential, shrinkage, ultimate, flexural and shear strength of composite sections, and deflections of composite beams, design of composite sections. Coming to the fourth unit, prestressed concrete slabs, types of prestressing concrete floor slabs, design of prestressed concrete one-way and two-way slabs, prestressed concrete pipes, circular prestressing, types of prestressed concrete pipes, design of prestressed concrete pipes. Coming to the fourth unit, continuous beams, advantage of continuity members, effect of prestressing intermediate structures, methods of achieving continuity, methods of analysis of secondary moment of second moment and concurrent cables profiles, Guyon's method, Guyon's theorem, redistribution of moments in continuous beam. Anchorage zone stresses in beams, anchorage introduction, stress distribution in end blocks, anchorage zone stresses, Magnell's method, Guyon's method, and anchorage zone reinforcement as per IS 1343-2012. So what is meant by prestressed concrete? As the name indicates, prestressed concrete in the form of concrete in which internal stresses are induced before its application so that it can counteract the tensile stresses produced in concrete due to external loads. So first go through the Frezonnet, the father of prestressed concrete, the Frezonnet. He was 1904. The credit goes to the the father of prestressed Frezonnet, French scientist. He demonstrated advantages and disadvantages of the prestressed concrete and high tensile steel and concrete used for and developing of the how to produce the high strength concrete and high strength steel, and double acting Jacques also invented the Frezonnet. So he is the father of the prestressed concrete structures. In India, the first prestressed concrete structure is built in 1948 under the Assam Rail Link project. Along the bridge, the Pamban Road Bridge at Rameswaram, Tamil Nadu, remain a classic example of use of prestressed concrete girders. So see this diagram. First, in India, bridge, Pamban Road Bridge at Rameswaram, Tamil Nadu. See this bridge. This is the first India prestressed concrete structure. So now go through the typical diagram for compared to the RCC and prestressed concrete structures. Generally, in reinforced concrete structures, cracked will be developed under the, so generally concrete in strong in compression, weak in tension. So that's why the reason the cracks will be developed in the RCC member. So now they rectify these cracks. Now introduce the prestressed concrete structure in Fresonate at the time of 1904. In India, the prestressed concrete structure is the 1948 in Rameswaram, Tamil Nadu, in Pamban Road Bridge. So now here the prestressing, first tendencies are to applying the prestress. So to applying the tensile, so under the service loads. To see this diagram, to dead load and prestressing tendons and fully service load. So this one is likely to uncracked member likely camber under the dead load and prestress. So what are the advantages of prestress? So the prestressing concrete has several advantages compared with the RC structure without prestressing. A fully prestressed concrete member usually subjected to compression during the service life. This rectifies the several deficiency of the concrete. First, go to the advantage. First, section remains uncracked under service load. Second advantage, high span depth ratios. Third one, suitable for precast construction. So now go through the first one. Section remains uncracked members, service loads. Reduction of steel corrosion and increased durability. Full section is unsteel and entire section subjected to compressive stress only. Higher moment of inertia, less deformations, increase in shear capacity, suitable for pressure vessels and liquid retained structures like water tanks, improved performance under dynamic and fatigue loading. Next, go through the high span to depth ratios, large span possible with prestressing bridges, buildings with long span columns, free spaces, etc. For the same span, less depth compared to the RC member, reduction in self weight, more aesthetic appeal due to the slender sections, more economical sections. Suitable for pre-construction. So the advantage of pre-cost construction as follows: rapid construction, better quality control and reduction maintenance, suitable for repetitive construction, multiple use of framework, reduction of framework, availability standard shapes. So the common type of precast sections generally used for the T section and double T section. It is used for generally metro constructions and hollow core and piles, L section, inverted T section, I girders. It is generally used for the metro construction, log span bridges, railways, sleepers, etc. These are the examples for the precast sections. So next, disadvantages of prestressed concrete. Prestressed concrete requires high quality, density concrete of high strength. High strength concrete in production, placement and compaction is required. It requires high tensile steel, 2.5 to 3.5 times costlier than mild steel. Prestressed concrete process requires complicated tensioning equipment and anchorage devices which are very costly. The prestressed concrete constructions requires very good quality control and supervisions. Prestressed concrete needs to more skilled labor. Prestressed is uneconomical for short span and light loads. So these are the most disadvantages of the prestressed concrete. So what are the limitations of prestressing? So and although prestressing has advantages, some aspects need to be carefully addressed. Prestressing skilled technology, hence it is not as common as reinforced concrete. This used in high strength material costly, so additional cost is auxiliary equipment and there is need for quality control and inspection. So these are the limitations of the prestressed concrete. The forms of prestressing steel, generally wires, strands, cable, tendon, bars. So these are the forms of the tendons. Generally wires, tendons, cables, these are the synonyms of the using the words wires, strands, cables. So generally strands refers to the two or more wires the twisted together to form a single wire, that is called strand. So tendon, cable, these are the group of wires. Bars generally more diameter comparatively, strands, wires, tendons, cable. So more diameter comparatively single wire. So these are the, if you see the diagrams, what is the bar and what is the wire, what is the strands, what is the cable. These are the group of wires stretched together and wire, bars, etc. So these are the forms of the prestressing steel. So types of prestressing: pre-tensioning or post-tensioning, fully limited or partially prestressing, uniaxial, biaxial and multi-axial prestressing. So now go through the first one, pre-tensioning or post-tensioning. So what is pre-tensioning and what is post-tensioning? So now go through the pre-tensioning member. So the cast is this is the most important classification based on the sequence of casting concrete and applying the tension to the tendon. So first go through the pre-tensioning. Tension is applied the tendon before the casting of concrete. The pre-compression is transferred from steel to concrete through the bond cover the transmission length near the ends. The following figure shows the manufactured the tension in electrical poles. General examples of the short span bridges like electrical poles, railway sleepers, etc. So these are the stages of the pre-tensioning. So anchoring of tendons against the end abutments, placing of jacks, applying the tension to the tendon, casting of concrete and cutting of tendons. So see the examples of the, see the manufacturing unit of the pre-tensioning. So this is the jack, this is the jack and this is the abutment, one end, other end is jack. To see this one. So what is the process of the pre-tension? So now applying the one end fixed, other end is anchorage, other end. So to applying the tension to the steel wires after pouring of, before pouring of the concrete. So now construction the concrete beam. So these are the pre-tensioning bed. So applying the tendon to the tension. So casting on concrete. So transfer to the prestress. These are the stages of the prestress. One end is end abutment, other one is jack is there. So to the anchorage. So these are the manufacturing unit process of the pre-tensioned concrete. So what is post-tensioning? So the post-tensioning, the tension is applied to the tendon. So located a duct. Duct means small gap. Duct means small gap. Small gap. So after hardening of concrete, the pre-compression is transferred from steel to concrete by the anchorage device. So at the end blocks, so now this is the duct. One small duct is places, trends are, strands are, cables are, wires are twisted together and the insert to the duct to applying the pull. This is called the cast of concrete, tensioning to the tendon. So one end jack, other end is anchor. So anchorage tendon to the stretcher end. So these are the manufacturing unit of the post tensioning. To see the diagram, These are the long span bridges, piles, etc. examples of the post tensioning members. So stages of post tensioning. So casting of concrete, placement of tendons, placement of anchorage block and jack, applying the tension to the tendon, seating of wedges, cutting of tendons. These are the stages of post tensioning. So see this place is called duct. This place is called duct. The cables or wires or stands are in the place of duct. So create a tension under the double acting use of the double acting jacks like this. So these are the duct. See this figure also. This is one of the manufacturing unit, metro pillars like that. So what is uniaxial and biaxial and multi-axial prestressing? As the same suggested, the classification is based on the direction of prestressing a member. So uniaxial prestressing, when the prestressing tendons are parallel to the one axis, so that is called the uniaxial prestressing. Example, longitudinal prestressing beams, example, railway sleepers. Biaxial, so prestressing tendons are parallel to the axis, it is called the biaxial. Examples, slabs. Multi-axial, when the prestressing tendons are parallel to the more than two axes, it is called the multi-axial prestressing. For example, prestressing domes. So now go through the why use for high strength steel and concrete for the prestressing. So generally the initial losses of prestressing is more due to the elastic deformation of concrete, creep, shrinkage of steel like that. So now it is the use of high strength steel and high strength concrete generally used for the pre-tensioning M40 grade concrete it is used, for post-tensioning M30 grade concrete are used. So the mild steel used in order to reinforcement as yield point 200 to 300 MPa. If such steel is used in the even, it is subjected to stress 200 MPa. At the stage of tensioning, we find it due to the creep and shrinkage of concrete, net tensile stress left over the extremely low. So generally more it is used for the high strength concrete, and high strength steel also it is used for the not used for the mild steel because of the initial stress 140 MPa in mild steel. So initial losses is more for the mild steel. So it is used for the high tensile steel. 200 to 2100 MPa steels are used. There will be large stress in reinforcement after making a deduction for the loss of prestress. Difference of prestressed concrete over the and reinforcement concrete. So generally it is used for the main key role of the steel in the prestressed concrete member. The stress in steel prevail whether the external loads is where they are not, but RCC steel play a role, the passive role. The stress in steel RCC members depends upon the external loads, that is no external load, no stress in steel. Second one, in prestressed concrete stresses in steel almost constant, whereas the RCC the stress in steel in variable with the lever arm. So lever arm means the distance between the tension to compression. So it is called the lever arm. Now go through that main difference is prestressed concrete has more resistance, whereas shear resistance of RCC is less. Prestressed concrete members deflections are less because the eccentric prestressing force will be induced with the couple which the cause upward deflections, whereas in the RCC deflections are more. In prestressed concrete, fatigue resistance is more compared to the RCC. Next one, the prestressed concrete is more durable as higher grade of concrete is used which are denser in nature in RCC. less durable. In prestressed concrete, dimensions is less because external stresses are counterable by the internal stresses induced by the prestressed concrete. So, generally it is used for the quality concrete reduction 30%, steel reduction by about 60 to 70%, and RCC uneconomical for the long span because in RCC dimensions sections are large requiring more concrete and steel. So, now go through the analysis of prestressed member. So, as per IS 1343 2012 clause 23.1 ultimate of limit state of collapse. So, these are the basic assumptions are there. First one is concrete is homogeneous and elastic material. Within the range of working stress, both concrete and steel behave elastically, notwithstanding the small amount of creep which occur in both the material under the sustained loading. A plane section before bending assumed to remain plane after bending, which is impulse a near strain distribution across the depth of the member. So, concept of the analysis, the prestressing, see the bar chart diagram, the stress concept of prestressing, force concept, load balancing concept. Now, the stress concept to applying the force to the member. So, now cross section of the beam. So, this is the eccentricity, the applying the force, the direct stress, stress due to eccentric of the prestressing, stress due to the external bending moment. To see the P by A and PE by Z, M by Z. So, equal to total resultant stress P by A minus PE by Z plus M by Z in upwards, and downwards P by A plus PE by Z minus PM by Z. So, these are the external moment, bending moment. So, to applying the load, so the direct stress, the prestressing force P by A. So, external loads due to the eccentric, the prestressing force plus or minus PE by Z. So, extreme stresses due to the bending moment plus or minus M by Z. So, these are the final stress at the top fiber and stress at the bottom fiber. So, see the diagram. So, like that, this is the load applying the direct stress. So, this is the eccentric loading. This is the movement due to the external bending moment. So, the top fiber and bottom fiber. To see the formulas, thank you.